Hello and a very warm welcome to Science Monitor, your weekly update on what's happening in the field of science, technology, research and innovation. I'm Frank Rausen Pereira. From an innovative device to detect oral cancer to a study that explains the mystery behind declining rate of star formation, we have plenty in store for you today. So let's begin with the headlines. Aditi Urja Sanch unit developed by CSIR NCL Pune indigenously designed cooking stoves to run efficiently on 100% DME and DME LPG blend. Thiruvananthapuram-based startup develops Oral Scan, a handy and high-tech imaging device to detect early stages of oral malignancies. Manesar-based National Brain Research Center develops multimodal neuroimaging database. ANSH also includes neurochemical data to advance research on Alzheimer's. And Indian astronomers succeed in measuring the atomic hydrogen content of distant galaxies. Study uncovers the mystery behind the declining rate of star formation. And now the news in detail. A pilot plant was set up last year at CSIR's Pune-based National Chemical Laboratory to produce DME from methanol dehydration. Using indigenous and patented technology, the pilot plant is now producing 20 to 24 kgs of DME per day. Now, to test this green fuel and its blend as a domestic cooking fuel, NCL scientists have also developed a new burner which is suitable for its combustion. Recently, the newly designed cooking stoves were launched for public use on a trial basis. Here's more.
National Chemical Laboratory, situated in Pune, is a constituent laboratory of the Council of Scientific and Industrial Research. Working towards methanol economy in the country, the lab has developed indigenous technology to produce eco-friendly and efficient fuel in the form of dimethyl ether or DME. The pilot plant to manufacture DME was established last year, and now the ultra-clean fuel is ready for public use. A few days before, in a virtual ceremony, the DME-fired Aditi Urja Sanch unit was launched by the Union Minister Dr. Harshvardhan with the indigenously developed burners designed for DME and DME LPG blend.
India's energy dependence on other countries could come down significantly with our findings from National Chemical Laboratories, and especially about the dimethyl ether technology, what we have found out. Okay, our research and findings about dimethyl ether production technology will give direct benefit to the common man. So it will bring down the LPG cylinder price 10 to 15%. I mean, about 100 rupees per cylinder will be brought down when this technology is commercialized. So that is a direct benefit to the common man.
Currently, the pilot plant at NCL is producing 20 to 24 kgs of DME per day. And the plan is to scale up the capacity to 0.5 tons or 500 kgs through CSIR Fast Track Commercialization Project. The pilot plant produces DME from methanol dehydration. The DME process technology is economical, cost-effective and scalable with in-situ product purification as well as heat integration unit that produces pure DME. The fuel can be used independently or can be blended with LPG. NCL plans to expand its use in other sectors as well.
This is called dehydration of methanol to DME. It can be used as a fossil fuel and chemical commodity and so much applications. So first, we are actually last week we have introduced the Aditya Urja Sanch. It's called the limitless energy units, which governs for the domestic fuel for the domestic family as well as industrial burners. And then later we are going for automobile industry as a fuel.
NCL has come up with specially designed burners for the complete combustion of DME and DME LPG fuel blend, as the density of DME is different from LPG. DME-fired cooking units are being used currently on a trial basis at the domestic level. Some NCL employees are also using these stoves. The DME project is moving on a fast-track mode from the laboratory to the market, and soon it will be available to the people under the methanol economy and green sustainable fuel policy of the country. Successful trial of the indigenously produced clean fuel in the domestic sector will give a big push to the Make in India campaign.
A startup incubated at Technology Business Incubator of Sri Chitra Tirunal Institute for Medical Sciences and Technology in Thiruvananthapuram has developed an innovative imaging device for quick and easy detection of oral cancer. The indigenously developed handheld device was launched on the 28th of October in Kerala under the name of Oral Scan. The device will help in reducing the mortality rate of the disease by facilitating early detection.
Oral cancer is a major concern in India. Every year, more than 80,000 cases of oral cancer are reported in the country. Mortality rate is quite high in oral cancer due to delay in the diagnosis. To overcome this problem, an indigenous screening tool named Oral Scan has been developed by Sascan Meditech Private Limited. The company is an incubated startup of Sri Chitra Tirunal Institute of Medical Science and Technology, Thiruvananthapuram. This innovation, with seed funding from Nidhi scheme of Department of Science and Technology, Government of India, will help in rapid diagnosis and detection of oral cancer.
This is the first time that a camera has been integrated into a handheld multispectral imaging device for oral cancer screening and biopsy guidance. The device can be scalable for detection of other cancers like the cervical cancer and the cancers of the GI tract and the aerodigestive tract.
Currently, to detect early stages of oral cancer, physicians rely on oral examination using a torchlight. This practice often fails not only to detect oral cancer but also in locating optimal site for biopsy. So, the patient has to undergo multiple biopsies, which delays the diagnosis and treatment of the disease, besides increasing the discomfort and expenditure. This problem is solved by the high-tech handheld image device Oral Scan. It aids in early detection of oral cancer and identifies the exact location for biopsy.
So the Oral Scan has a loop mechanism of collecting the data from the field and analyzing it on a cloud-based software, and in real time it gives back the analysis results back to the device.
After successful clinical trials, Oral Scan has been launched commercially. Supported by Biotechnology Ignition Grant of BIRAC and Invent of DST along with the Kerala Startup Mission, this device has also received an Indian patent. Use of this indigenous device will surely benefit the doctors as well as the patients.
Well, now it's time for a short break, but stay tuned. We'll be right back. Welcome back after the break. You're watching Science Monitor. Well, researchers all over the world are studying neuroimaging data to arrive at the etiology of Alzheimer's disease. But the existing databases lack the integration of magnetic resonance spectroscopy, which limits the availability of neurochemical information to the research community. Now, equipped with its large-scale research in neurodegenerative disorders, Manesar-based National Brain Research Center has prepared a multimodal neuroimaging database called ANSH, which also includes neurochemical data. This database will help the researchers to arrive at better results pertaining to Alzheimer's.
Alzheimer's is a major neurodegenerative disorder and the most common cause of dementia. Unfortunately, with each passing year, the patients of Alzheimer's are increasing globally. Although physical and biological abnormalities of the patients have helped in understanding the disease, yet no treatment could be developed to cure it. Researchers at Manesar-based National Brain Research Center are also working on Alzheimer's through brain mapping and brain imaging techniques. And over the last decade, the NBRC researchers have arrived at significant findings through their studies. The center has performed neuroimaging on nearly 3,000 people and has gathered the complete brain data of 1,300 people, including the healthy control group and the patient groups. Now, the center's neuroimaging and neurospectroscopy laboratory has created a multimodal neuroimaging database, ANSH, which also includes data on neurochemicals. This effort will aid in the prognosis of the Alzheimer's and help in identifying its causes.
This 10-year journey, we have available made about 1,300 people brain scan. We did it here. All high quality data using our state-of-the-art machine called Philips 3T machine. We thought that why not? The whole world should get the data, reanalyze it, find something new. So we have given a novel hypothesis and proved in a patient that this data is related to the cause of the disease. That means we have gone to the closer to the Gangatri of the river, so we can find the that real truth of the disease, and we are close.
Brain imaging data of NBRC includes magnetic resonance imaging and magnetic resonance spectroscopy, along with the neuropsychological data of the patients to get an insight into the patient's behavior. After analyzing and correlating these factors, the condition of human brain is assessed and the disorders are identified. Comprehensive data is crucial not only for diagnosing diseases like Alzheimer's, but also for predicting their causes.
I do the neuropsychological assessments over here, which includes certain tests, neuropsychological tests, which can give you an idea whether one person is having what kind of impairment. MRI imaging findings के साथ we correlate the result of neuropsychological assessment. Brain का image लेके उसका एक result निकालना और behavior का result निकालना. We do correlate those two findings and we do our research work over here.
This unique initiative is funded and supported by the Ministry of Science and Technology and the Ministry of Electronics and Information Technology of the Government of India, along with the Indo-Australian Biotechnology Fund. ANSH is the first platform where antioxidant, neurotransmitter, and energy metabolites are discussed along with the other data types. The development of ANSH platform will facilitate collaborative research and multi-site data sharing across the globe, and hopefully will also help in developing its treatment.
Using the upgraded Giant Meter Wave Telescope, Indian astronomers have succeeded in measuring the atomic hydrogen content of around 8,000 distant galaxies. According to the astronomers of National Centre for Radio Astrophysics, Pune and Raman Research Institute of Bangalore, the findings of their study explain the declining rate of star formation to a great extent. The joint research has been published in the journal Nature.
Stars The twinkling objects in the sky have always attracted human attention. But according to astronomical studies, the rate of star formation in the universe is dropping continuously after it peaked about 8 to 10 billion years ago. And the astronomers are wondering what happened in the earliest epoch of the universe. Recently, a team of astronomers from the National Center for Radio Astrophysics of the Tata Institute of Fundamental Research, Pune, and the Bangalore-based Raman Research Institute has managed to answer this question. The astronomers have succeeded in recording the earliest epoch in the universe by measuring the atomic hydrogen gas content of the distant galaxies as they were 8 billion years ago. Their study has deciphered the mystery behind the decline in the star formation activity, and the research has been published in the research journal Nature.
In general, to understand galaxies, you must measure the hydrogen content. And so people are trying to do this, independent of the star formation issue, people are trying to do this for a long time. And so this is a way, and the highest redshift at which this has been done, or the earliest in the universe this has been done until now, is about 4 billion years ago. So now we've gone back to about 8 billion years, double the time distance that we can do this at. And this epoch, which we are finally measuring the gas mass in, is a very interesting epoch in the universe, because that is when the star formation of the universe peaked. The star formation rate in the universe, star formation rate density. Galaxies are forming stars very efficiently then.
Galaxies contain a lot of gas, mainly the atomic hydrogen that converts into stars with time, as it is the primary fuel for star formation. But unlike stars which emit light strongly at optical wavelengths, the atomic hydrogen signal lies at the radio wavelength of 21 centimeters, and therefore can only be detected with a radio telescope. The giant meter-wave radio telescope at Pune was designed and built in the 1980s and 90s for the same goal. With the earlier version of GMRT, astronomers could study only 850 galaxies for similar research in 2016, but that wasn't enough. The situation changed with the upgradation of GMRT in 2017, which enabled the scientists to detect the signals of about 8,000 galaxies dating back to 8 billion years. As the 21 centimeter signal is fairly weak, so it was not possible to detect the signals from the individual galaxies. To overcome this limitation, the team used a technique called stacking to combine the 21 centimeter signals of nearly 8,000 galaxies and measured the average gas content of these galaxies.
There is a limited amount of gas and there is no more gas falling into the galaxies. So after some time, all the gas will get converted to stars, and that's when you will expect the star formation to start declining. And what we find is that there's just enough gas for the star formation to sustain for about 2 billion years, 1 to 2 billion years. So after 1 to 2 billion years, from our measurements, we would expect that the star formation rate would start to decline. And this is exactly what we see, that the star formation rate, what we have known for 2 decades now, that the star formation rate declines after it, from that epoch, after it has peaked from 8 billion years to now.
The research funded by the Department of Science and Technology and Department of Atomic Energy not only highlights the successful collaboration of Indian astronomers at NCRA and RRI, but also the telescopes like GMRT that allow us to peer into the universe to unravel its mysteries.
Well, it's time now for another short break on the program, but stay tuned, we'll be right back. Welcome back after the break. You're watching Science Monitor. I'm Frank Razan Pereira, and now let's have a look at some other developments that have made news in the field of science and technology in our segment, Science Express.
The Indian Institute of Technology, Kanpur and the Archaeological Survey of India have signed a memorandum of understanding with two Italian institutes based in Venice on creating and sharing skills for restoration and protection of historical monuments. Under this MOU, all institutes have agreed to create a network in which scientific studies, skills and experiences for the restoration and conservation of monuments will be shared. Under this network, a special plan will be worked out for each activity depending upon the availability of resources and the conservation needs of the monuments.
Kanpur, Archaeological Survey of India, the University of Venice, Italy, and equivalent archaeological survey of in the Venice region where most of the monuments are there. So idea is that we'll exchange the information, we'll take the field assessment of monuments, and then what technology could be applied to improve the monuments and their increase their longevity, and also especially the effect of pollution, especially the air pollution on the monuments, and how these things can be restored and made to last longer.
NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA, has confirmed for the first time water on the sunlit surface of the moon. Using its faint object infrared camera, the telescope was able to pick the specific wavelength unique to water molecules at 6.1 microns and discovered a relatively surprising concentration in sunny Clavius crater, which is also visible from the Earth. According to the researchers, the water could be trapped in bead-like structures that form due to micrometeorite impacts, or it could be hidden between the grains of lunar soil sheltered from the sunlight. It should be noted that ISRO's Chandrayaan-1 also indicated the presence of water in the polar regions of the moon. But the new discovery shows that even the sunlit part of the moon can contain or retain water molecules. The new discovery has raised hopes for building base camp on the moon. According to an Indian study published in the journal Nature Geoscience, intensive irrigation in India is increasing the atmospheric moisture levels and enhancing the extreme heat stress conditions. Study refers to deadly dry heat stress and moist heat stress, which occurs when the human bodies do not cool down easily as a result of high temperatures or due to high temperature coupled with humidity. The study states that the irrigation sector of India has doubled in the last few decades, and the associated moist heat stress is directly related to human mortality. Researchers believe that human-induced climate change could lead to higher temperature levels, thereby affecting all who work outdoors. According to the Indian Space Research Organization, Mars is losing its outer atmosphere at a faster rate. ISRO has arrived at the result by studying the data and images sent by its own Mars Orbiter mission and NASA's Mars Atmosphere and Volatile Evolution mission. The data and the images show that a global dust storm enveloped the planet for about a month in 2018, which heated and expanded the upper atmosphere of the red planet, leading to enhanced escape of Martian atmosphere. As such storms are not uncommon on Mars, so it is inferred that Mars must be losing its atmosphere rapidly. This loss is determined mainly by the size of the planet and the temperature of its upper atmosphere.
Well, that's a wrap on this edition of Science Monitor, but we would like to hear from you. Do send us your feedback and your suggestions through email. Our email ID is news@vigyanprasar.gov.in. You can also write to us. Our address is Vigyan Prasar, 5th floor, Prithvi Bhavan, Lodi Road, New Delhi, 110003. That's it from me. See you again next time.